Here's an example where you can use the impulse momentum theorem. So press pause, read through this, work through it, and then press play when you're ready to go through it with me. Okay, so I'm given a force, and that force is changing as a function of time. So I know that, first of all, I'm not going to be able to use kinematics in this problem because the force changes as a function of time. So what I am going to do is use the impulse momentum theorem. And I can figure out the impulse by taking the area under this graph. I have a triangle that's a nice easy shape to take the area under. That's going to give me my impulse, and then my impulse can be set equal to my change in momentum, and that's going to let me figure out my final speed because I know that initial speed. So as we're going to start to do in all problems that involve momentum, we're going to set up our events, and we're going to be very careful about our events. Whenever you have a collision, you always want to have an event right before the collision happens, and you want to have an event right after the collision happens. And you need to make sure that whatever is happening before and after the collision, you kind of have it in the right column. So initially, I have some initial momentum that's going to be equal to my mass times my initial velocity. Remember, momentum is a vector, so we do care about direction. This is an object that's going to bounce on the ground, so initially it's falling downwards. I have to take that initial speed of 6 meters per second and make it negative. My mass also has to always be in kilograms. So my mass is going to be 0.1 kilograms. My initial velocity is negative 6 meters per second. So my initial momentum is negative 0.6 kilograms meters per second. After the collision, I don't know what my velocity is. That's what I'm trying to figure out. So I'll just write this expression for my final momentum. Now I can figure out my impulse by taking the area underneath this graph because I have a force versus time graph. I'm just taking the area of that triangle, so that'll be 1/2 times the base times the height. And I need my units to be in seconds and newtons. So these units here are milliseconds. That's like a millimeter, but this is millisecond. So that's, instead of 6 here, it's going to be 0.006 seconds. It's 6 milliseconds or 0.006 seconds. I need my units to be in seconds. And then the height of that triangle is 350 newtons. So I find that my impulse is 1.05 kilograms meters per second. Now that I know my impulse and my initial momentum, I can figure out my final momentum. So I'm going to say my impulse is equal to delta P, where delta P can be written as P final minus P initial, and P initial is negative 0.6. That lets me solve for P final. Once I know what P final is, I can come back over here to figure out what V final is based on my mass. Here is another example, so press pause, take some time to work through this, and then we'll go through it together. So in this problem, I'm given a graph, and the graph shows me my initial velocity and my final velocity. The collision that's happening, and this is a puck colliding with a wall, the collision that's happening, that's the thing that changes my velocity. So initially I'm traveling with a constant velocity. When my velocity changes, it's because there's a force acting on me, and that force is changing my velocity. At this point right here, where my velocity is 0, that's when the object is at rest. That's when that force is at its maximum. And then here my velocity is complete, and now I rebound, and I happen to be rebounding with the same speed I came in at, just in a different direction. And this is what the force looked like during that collision. This is the force on the hockey puck. I don't know the time that it takes place over, though. So let's try to figure it out. I know, in this case, I know my initial and final velocities, so I can figure out my change in momentum, and then I can set that equal to this area. So again, I'm going to look at before my collision and after my collision. My momentum before the collision, there's my mass written in kilograms. My initial velocity is negative 2 meters per second, so this is my initial momentum. And then after the collision, the only difference is that now my velocity is positive, so this is my momentum after the collision. So from these two values, I can figure out my change in momentum and my impulse, and I get that my impulse is 2.4 kilograms meters per second. That means the area underneath this graph has to be 2.4 kilograms meters per second. I'm just taking the area of a simple triangle, and the width of that triangle, or the base of that triangle, is delta t. That's my unknown, and I can solve that. I get 0.06 seconds, or 6 milliseconds.